Hey class, so here's this next question where kind of a unique situation. We got this 10 kilogram block, it's being released on a frictionless track at point A where it slides down and curves out and eventually is moving horizontally instead of straight vertically. Then from B to C, it encounters this bumpy region, which we're told is going to exert a force of kinetic friction on it, and we're actually asked to find the coefficient of kinetic friction acting upon it as it slides to a stop. So again, this is a very odd and unique situation here, but something that you can do, and why this is a tricky question, is if you look from A to B, the only force acting on it is gravity. Even though the direction is changing, we know that gravity is moving and acting over a vertical distance of just 3 meters. So even though the total distance it's going to move is more than 3 meters, the vertical distance is 3 meters. So you can actually treat this like an object in free fall moving vertically for 3 meters. So again, I didn't expect everybody to know this, and we'll actually prove why this is true when we get into talking about energy. But this is kind of like bonus level question here. So we can treat this as if it's kinematics, where you have an object that has an initial y position of 3 meters, a final y position of 0 meters, an initial y velocity of 0 meters per second, and a final velocity that we're trying to find, which again will act as if it's the y final velocity, even though it's changed direction and been redirected by the track. And we know that our acceleration is just going to be negative g, and we don't know how long this takes. So we can use the kinematic equation of motion that ignores time to find that final velocity, because we know it's going to be v initial y squared plus 2ay y minus y initial. And so that v squared, that v final is just going to be the square root of, since this is 0, 2 times negative g multiplied by 0 minus the 3 meters. And so what you should find is that that speed that it has there at the bottom is 7.67 meters per second. Now, once again, you could think about kinematics from B to C, because we know now VB is going to just be our 7.67 meters per second. VC will be 0 because it comes to rest. We know XB is just 0. XC is 46 meters. And AX, we don't know, and the time, we don't know. So, we need to figure out the acceleration then in order to be able to figure out the coefficient of friction, because acceleration is the thing that connects us to friction. And the reason I know this, if I go ahead and slide over a little bit here, if I draw a free body diagram for my block from B to C, I have a normal force going up, I got the weight force, or the force of gravity, going down. No forces forward, just inertia carrying it forward, and a force of kinetic friction going back. So sum of the forces in the x direction equals max, and sum of the forces in the y equals may, and in the y direction we have the normal force minus the weight equals 0, so we know a normal force is just equal to the weight. And in the x direction we just have the coefficient of kinetic friction times the normal force. That's it. Force of friction equals ma. So we actually have mu k mg equals ma. The masses actually cancel, so mu k is just going to be our acceleration divided by g. So if we can solve for our acceleration, then we should be able to solve for our coefficient. So coming back over here, we can actually use the same kinematic equation of motion, vc squared equals vb squared plus 2a xc minus xb. And now we can again solve for a here, because we know that this is 0, so a is just going to be negative vb squared over 2 xc minus xb, and xb is 0, so you could plug that in, but we have a equals negative 7.67 meters per second squared. Oh, that's a terrible square. Let's try that again. Squared over 2 times 46 meters. And so what we should find is that our acceleration comes out to be negative 0.640 meters per second squared. So it's pretty small acceleration, which means we must have a pretty small coefficient of friction. But if we go ahead and plug that in over here, mu k is going to be equal to, now we're just going to plug in the magnitude of 0.640 meters per second squared because we know the direction already is going to be backwards. And technically both of these should have been negative, but I just defined the positive x as to the left to make my life easier. Over 9.8 meters per second squared. So we get a coefficient of kinetic friction that is quite small, nearly frictionless, but 0.0652. Boom, box worthy. Awesome. Well, hope those all helped. Hope you guys are having a great day and keep up the good work.